Python package called NetworkX. So just a show of hand, who's used NetworkX before? Just one? Okay. So if you have a lot of data that's graph or network related, you'll like NetworkX. So I've contributed very minimally to the project under the Google Summer of Code, but I use it a lot on a day-to-day basis. And there's a lot of algorithms implemented in it. There's stuff from combinatorics, a bunch of stuff from network analysis, and some optimization algorithms as well. And it's easy to visualize the graphs via the use of Matplotlib. So just a refresher of a graph. So networks or graphs consist of vertices and nodes. You have singletons in your model. This is what you consider as vertices and nodes. And then you have edges, which are connections between the vertices. All right. So hello world for NetworkX looks like this. You create a G, graph G, and then you're going to add the edge iteratively. So 1, 2, 2, 3, 3, 4, 3, 5. And you can query the nodes very easily. You get the nodes 1, 2, 3, 4, 5, and you get the edges 1, 2, 2, 3, 3, 4, 3, 5. And you can visualize this. It looks like that. So you have the nodes and edges, right? A more complicated graph is this. This is all the graphs with nodes, 6 nodes or less. Yeah, this is created with NetworkX and Matplotlib. So we'll do some data analysis now. There's some free data available, and it's on a network of books about US politics, published around the 2004 elections, and it's sold by the Amazon, right? And edges between the books represent frequent co-purchasing of books by the same buyers. So if you have an edge between 2 books, it means that the 2 books get bought together at the same time in one checkout. So if you were to query the nodes, you'll get this kind of stuff. You get nodes 0 to 10, and each node is a book. There's a title for each book. All right. And the edges is just the co-purchasing between nodes. You don't have a lot of information. You just have the edge. If you want to visualize it with Matplotlib, it's very easy. You get this kind of graph. It's very messy, right? So it's better to really prune your analysis so that you can get a better view of the data. So we'll do clique analysis. So a clique is basically a set of nodes in a graph that have edges between them. So pairwise, you take them pairwise, you have edges between them. In this case, you can find cliques very easily with NetworkX. There's a function for that. And you get the cliques, and you get the length. And we can get some simple statistics of the cliques. So for example, we can get the maximum clique length, which is 6. So at any point of time, at most 6 books are purchased together in the same checkout in Amazon. And the average clique length is 3.7, so on and so on. And the number of cliques is 199. All right. So some intuition for the cliques. Again, they are the set of books that are bought together, often bought together. So when the data was collected, an edge is drawn when the book gets bought like more than 50 times. So that's pretty good recommendation. So for example, if we just query the cliques of size 6, we get these kind of books. So these books for each list are bought together a lot at the same time. Yeah, I'm not too sure what they are. Yeah. And then you can visualize those cliques, actually. So you just take the graph, the previous graph that's really big, and just take the subgraph of that. Take the vertices of the cliques that you took for the largest clique, and you plot that. And surprisingly, you get 2 clusters. So they're disjoint. And this is very easy to see with NetworkX because you can visualize this just like that. All right. That's all.